Okay, so we're going to look at the last 2 pages from our study guide for Honors Pre-Calculus second semester exam. 55, 56 will not be on the exam. If they are on the exam, I will give you the solutions to those 2 problems, or those problems that are like it on the exam. We did not cover that. But we covered this stuff, but it was all new for you, I believe. So what is the center and radius of the sphere? So to find center and radius, I need to complete the square on x, y, and z. So I'm going to group my x's, x squared minus 2x, leave a blank, group my y's, plus y squared plus 4y, leave a blank, group my z's, plus z squared minus 6z, leave a blank, and subtract 8 on both sides. It's equivalent equations. Now, completing the square, half of negative 2, negative 1 squared is plus 1. And we're out of balance. Half of 4 is 2, 2 squared plus 4, and we're further out of balance. Half of negative 6, negative 3 squared is plus 9. And we're out of balance. So I'm going to add 1, add 4, and add 9 to the other side to get back in balance. And we've got x, JT, could you close the door? And thank you. And we've got x minus 1 squared plus y plus 2 squared plus z minus 3 squared equals, what do we have here? 10, 14, 6. Therefore, our center is at my box, my voy, my vase, and the radius is square root of 6. Okay. Pretty simple at this point, I think. Okay, 58. Find the distance between. So we're in 3 space here, but the distance formula is exactly the same as the distance formula in 2 space, but we have z's to consider. So my distance between those is 0 minus 1, square root of 0 minus 1 squared, plus 1 minus 4 squared, plus, still not long enough, 3 minus negative 2 squared. So we get root 1 plus negative 3, 9, plus 5, 25, or root 35. Okay. Okay. What is the component form of the vector? So this I would have described as like we're pushing the chair. And its x component, I went from 3 to 4, so we increased by 1. But you can just do this backwards. The vector is going to be 4, subtract backwards, 4 minus 3, 4 minus where we started from. I ended at negative 2, I started at 1. I ended z component at 7, I started at negative 2. So we end up with 1, negative 3, 9. And it's worth taking a second and checking that. Increased 1, decreased 3, increased 9. There's our component form. Nice thing on multiple choice exam, if they say component form, and you're like, oh geez, what's component form? Well, it won't take you long to figure it out when you look at the distractor answers, or at the answers. Magnitude of a vector is just the total distance that we traveled. This is the component form, which means we pushed it 3 in an x direction, we pushed it negative 1 in a y direction, and we pushed it 8 in a z direction. It's really the same question as this, except this means we started at 0, 0, 0. So it's square root of 3 squared plus negative 1 squared plus 8 squared. Or 9, 10, and 64, root 74, which I do not believe we're going to be able to simplify that. The angle between. Well, the angle between they say cosine of theta is u dot v on magnitude u times magnitude v. And that's what we do for in 2 space. It's also what we do in 3 space. So I want 3, -1, 8 dotted against 7, -1, -5 on the magnitude of 3, -1, 8. That's kind of nice. We just got that one. Root 74 times the magnitude of 7, -1, 35. And I'm just going to do a little sidebar for that one. So that would be root 49 plus 1 plus 25, or root 75. Now, if I want to solve that for theta, that would just be cosine inverse of all of that. So what do we get here? Sidebar, 21 dot products. Remember it? 21 plus +1 plus -40. So 22 minus 40, I get -18 cosine inverse of -18 on root 74 times root 75. And at that point, good time to go to calculator. Now, what do we want? Do we want the answer in degrees or do we want the answer in radians? Could be in either, but looks like, based on the question, we want it in degrees. Let's make certain we have our calculator set in degrees, and you guys can confirm with me on this one. So let's clear second quit. Mode. You guys will be done before I am. Degrees. Cosine inverse -18 divided by, maybe the most likely place we're going to make a mistake here is by not putting the entire denominator. Do I have a, yeah, it should be 18. Thanks. The entire denominator. And I can just do that one big square root. I could just go square root of 74 times 75 like that. How does that one look for us? 103.98. I'm seeing nodding heads. That's good. 103.98. Yikes. Awful. Okay. No problems there? All right. E.T. meets up with Elliot here. We're looking for what is the limit of the graph as x approaches 0. Well, the graph doesn't exist at 0. So does that mean there is no limit? No, we have a limit if from the right and from the left we can agree on where we would meet. So we get right up close to it. Our limit is 2. Okay. What is the limit of the graph as x approaches 2? Well, from the right, as we approach 2, we're heading there. From the left, as we approach 2, we're heading there. That couldn't be more. The limit doesn't exist. Okay, reminder on that. Because here's a common graph we might see where we have an asymptote. Let's say this is at 3. The limit at 3 does not exist either, even though we're going to say, well, they both agree it's going to infinity, so we would say, okay, the limit's infinity, but infinity is not a number. Infinity doesn't exist, it's just a concept. Okay, so there's no limit in that case either. Other cases where limits don't exist might be something like that. That limit, we would say, does not exist at 2. Even though the function exists at 2, Elliot thinks we should be up here, E.T. thinks we should be down there. Okay. All right. Find the limit. If I didn't have a calculator, the first thing I would do is I would put -3 into this function. And if this became 9, if I put -3 and I get 9, I'd say the limit is 9. If the numerator became not 0, let's say 6, and the denominator was 0, the limit does not exist. If the numerator is 0 and the denominator is not 0, 0 over 7, the limit's 0. But if the numerator is 0 and the denominator is 0, now we have a hole in the graph. The limit exists, but I don't know what it is. So what I could do in that case is I could long divide x plus 3 through these guys, or synthetically divide 3 through these, -3 through these, and factor it out, and then try putting -3 in again. But if we're taking a final and we got access to our calculator, I can go ahead and enter this one in our calculator. So I'm going to go through that. We did it the other day. You're welcome to go through that with me just as a test here. We did it the other day, but feel free. So I think I need to change my mode. I think I'm in polar right now. So back to function. Degrees doesn't matter. Y equals, ooh, I'm in luck here. I've got that function in already. So you can catch up with me if you'd like. I'm just going to go zoom standard. And what becomes clear to me is I believe we got an issue around -1, probably at -1, but around -1 we got an issue. But we're not talking about -1. We're talking about the limit as x approaches -3. And we look at the graph, and it appears like at -3, Cubs win twice in a row, Kevin. As we get to -3, it appears as though it should exist. So I might just go straight to trace and just enter -3. And when I enter -3, my calculator tells me the function does not exist at -3, but it sure appears like we're in agreement at -3. I could, for instance, zoom box this. Love zoom box. I'm going to zoom box around -3, build a little TV screen here. Enter. Enter. And it sure looks like it exists there. The best way to do this, now I could trace here. I'm going to go trace, and I'm going to put in -3, and we're going to see it doesn't, it must not have done that right. Let's try that again. Let's go back to graph, and I'm going to trace, and I'm going to try that again. Am I going to get an error again here? I am. Why is that? What's my window? Huh. I must not have included -3. Let me do this again. Xmin. I'm just going to go like -3.5 to X max -2.5. I must not have built my window in the right, or my box in the right spot. Okay. So try that again. You actually can see a little tiny break there. Can you see that one? And you think my calculator is missing a pixel, but I think my calculator must have tried to graph that point. So I'm going to go trace -3, and it doesn't exist. And if I bump just a little bit to the right of that, I get 0.498. A little bit to the left of that, 0.501. There's reason for me to believe that we're in agreement around 0.5. Probably the better way to handle that is to go back to your table set, or go into your table set. Here I'm starting at, I'm just going to start just to the left of -3, -3.0001, for instance. And I'm going to count by, say, 0.000, oh boy, is that going to be okay? Ones. I'm going to count by that. And then I'm going to go into my table, second table. And I see this must be the true -3 right here that's an error. This is slightly to the left, just rounded. And I see, well, we're at 0.50002 and 0.4999. Does that mean that we're in perfect agreement at 0.5? No, but there certainly is reason to believe that 0.5 is where we would agree. There's where we would meet. So the limit at -3, I would suggest, is 0.5. Is that okay? There's algebra ways to do it, but be happy if you get it done with your calculator. And this one we should have no problem after JTBs with. Find the slope formula. F prime of x is 12x squared minus 4x plus 3. Cannot imagine that we would miss that. Just, do we know how to interpret it? What is the slope of this function when x equals 4? Well, that's what a derivative or slope formula is for. F prime of x is 2 times -3 halves -3x plus 2. We just want f prime of 4. We want to know what is the slope when x is 4. Well, that's -3 times 4 plus 2, -10. Simple. Okay. So that takes care of the final 2 pages. And I'm going to put, this is your photo moment, your Kodak moment. If you'd like to take a picture of that, if you weren't here yesterday, it'll also be on the video. It'll be on the front of the website, purpleshirtednerd.com. I believe those are all accurate at this time. Good luck. Let me know if I can help you with anything.